Imagine yourself on board a spaceship, gliding through the cosmos towards a frontier that, until recently, only inhabited the territory of dreams and intergalactic adventure stories. We are living through an unprecedented moment in the chronology of humanity, the age of space exploration. It is no longer a chapter in a science fiction book, but a palpable, vibrant, and challenging reality. In this scenario of discoveries and achievements, Mars stands out, not just as a bright spot in the night sky, but as the potential stage for humanity's greatest adventure to date. But while we daydream about our feet touching Martian soil, an intriguing question dances on the fringes of our thoughts. As we take this giant leap for mankind, as we venture beyond the familiar gravity of Earth, how would time treat us? Would we find ourselves younger on Mars, defying the limits imposed by the passage of time on Earth? Or would we become older, each second stretched by the distance from our planetary home? The answer to this question takes us into even more fascinating territory, where physics meets philosophy and time. This concept that is so familiar and yet so enigmatic reveals its elastic and mysterious nature. On this interplanetary journey, we not only explore new worlds, but also delve into the depths of human understanding, challenging what we know about life, the universe, and, of course, ourselves. So, before you start packing your bags, imagining your clothes floating in a starship cabin on the way to Mars, allow yourself to dive into this enigma. Ponder time, that river that flows differently depending on where you are in the vast ocean of space. And as we prepare for this monumental leap, remember, we are not only exploring the space around us, but also expanding the space within us, where our greatest discoveries lie. One of the most provocative enigmas that physics has shown us is the twin paradox, a story that seems straight out of a science fiction novel, but which is actually one of the most surprising and counterintuitive results of the theory of restricted relativity proposed by the genius Albert Einstein in 1905. Imagine, if you can, two twin brothers, identical in every way, whose lives take radically different paths due to a cutting-edge space program. While one of them settles into the routine of life on our familiar blue planet, the other ventures out on a space journey aboard a spacecraft capable of reaching speeds approaching that of light. This ship, a marvel of human engineering, is capable of distorting perceptions of time and space like never before. For a decade, the astronaut twin travels the cosmos, witnessing unimaginable wonders, while his brother continues his life on Earth. When the space traveler finally returns, something extraordinary happens. Although they were both born on the same day, the space-traveling twin finds his brother visibly older. While the astronaut has only aged 10 years during his odyssey, his brother on Earth has aged 20 years. This phenomenon, known as time dilation, opens a window onto a reality where time is not a river that flows uniformly and unalterably, but rather a flexible entity that can stretch or compress under certain conditions. Speed, in this case, speeds close to that of light, and gravity, such as that exerted by planets and stars, are the keys that can unlock this flexibility of time. Now imagine the implications of this concept. The twin paradox is not just a trick of the mind or an academic curiosity. It represents a fundamental challenge to our understanding of the universe. It invites us to rethink our notions of aging, distance, and even reality. What would it be like to live in a world where your age could depend not just on how many years you've lived, but on how and where you've spent those years? In this new world, time and space are no longer static stages where life and matter simply happen. They become the main actors in a complex plot, where gravity can bend light and speed can distort the passage of time. As we explore these distant frontiers, whether through the most powerful telescope or the most advanced particle accelerator, we discover that the universe is much stranger and more wonderful than we could have imagined. Einstein, with his genius, questioned Newton's equations, especially the perception of time as something absolute. He taught us that time is relative, influenced by speed and gravity. This understanding changed forever the way we see the universe and our place in it. Have you ever wondered what it would be like to call the planet Mars home? An idea that, until recently, seemed reserved for science fiction books, but is now knocking on the door of possibility. But here we are faced with an intriguing question. If we decided to establish our lives on the red planet, how would gravity, significantly lower than on Earth, influence our experience of time? Imagine for a moment you, a new age adventurer, spending a season on Mars. Every step is a reminder of the gravity there is only about 38% of that which shaped our bodies and perceptions on Earth. But when you decide to return to our home planet, a temporal conundrum unfolds. When you meet again those who chose to stay, will you find yourself older or younger than them? The experience of time, something we think of as universal and constant, actually shapes and adapts to the invisible forces that govern the universe. On Mars, this cosmic dance between gravity and time could mean that, yes, when we return to Earth, our relative age could be different from that of our friends and family who stayed behind. Depending on the length of stay and the speeds reached on the return journey, we could find a world that has moved on, while we lived in a slightly different fraction of time. Therefore, when contemplating the red immensity of Mars, we are not only dreaming of new geographical horizons, but also of new frontiers of time. A journey to Mars is not only a space adventure, but also a journey through time. And speaking of space travel and the fascinating manipulations of time, I can't help but recommend a movie that captures the essence of these issues with a gripping and visually stunning narrative: Interstellar. This cinematic epic takes us on a journey through the cosmos, where the relativity of time is not just a background theme, but one of the central pillars of the plot. In Interstellar, we follow the saga of a group of explorers who cross a wormhole located near Saturn on a desperate mission to find a new home for humanity. The film, directed by the visionary Christopher Nolan, masterfully explores the implications of Einstein's theory of relativity, especially when one of the characters travels to a planet near a black hole where time dilates dramatically. The emotional impact of this time travel is palpable when the character returns to the mothership, only to discover that, due to the intense gravity of the black hole, much more time has passed for those waiting on the ship than for him on the planet. This is a perfect example of how relativity can distort our perception of time, illustrating the paradox we discussed earlier. Interstellar not only keeps our attention with its gripping story and breathtaking special effects, but also invites reflection on profound issues such as love, sacrifice, and the fate of humanity, all intertwined with the fundamental laws of the universe. If you're fascinated by the idea of time travel, space exploration, the wonders and enigmas that the universe has to offer, this movie is a must-see. Get ready for an adventure that goes beyond the boundaries of human knowledge, challenging not only our understanding of time, but also the human heart itself. So, what do you think? Would you embark on this journey to Mars, becoming one of the first humans to set foot on the red planet? Share your thoughts and join us on this ongoing journey of discovery. Thank you very much for joining me in this conversation. See you next time.